Hello, what is going on, folks? This is Chris at Verlo Trading. Welcome to today's video. In today's video, we're going to talk about the difference between automatic looping in sierrachart studies and manual looping in sierrachart studies. So maybe this is kind of a remote topic, but it's going to help with traders who use sierrachart, who also use the advanced custom study language to program their own custom studies. I want to share with you guys some information based on tests that I've done using automatic looping and manual looping for various study functions in sierrachart. So I've made a few discoveries. Let's get to it, guys. If you enjoyed this content, let us know down below, make comments, all this kind of stuff. I'm interested in talking with you guys all the time, learning, becoming more knowledgeable, and just getting better overall every day. That's what we're trying to do. So thanks for watching, guys, and let's get to it right now. So I have a chart here open for the S&P 500 futures. So I'm going to start by reading through you guys some of my text document here. So the original question was, why does sierrachart use auto looping for the moving average and standard deviation studies? I have now found the answer and gained some insight by doing tests. Okay, so I guess you guys have to first understand what is auto looping and what is manual looping. Okay, so I'm gonna first go ahead and show you guys a study function. For example, moving average exponential. This is an exponential moving average here. This is the difference between auto looping and manual looping. So in this case, this study here has sc.AutoLoop equals 1, which means auto looping is turned on. Whenever there is a study function called that makes a reference or has to access data from the chart bars on the chart, with auto looping, it needs to iterate through every single bar on the chart, okay? With manual looping, you need to specify the array size for how many bars you want it to iterate through. And now, of course, logically, manual looping has the potential to be a lot more efficient, but in some cases, you might not need to do that, or you might not even be able to do that, depending on what the study is and how you want it to display on your chart. As the first example, I'm going to add a moving average study to the chart. So I'll go ahead and select Analysis and Studies. Then I'll find the moving average simple study in the drop-down menu here. I'll add it to the chart and I'll select Apply. Now, normally when people use moving average studies, and potentially even other things like VWAPs or standard deviation, any study that sort of draws something on your chart over a long period of time, normally these types of traders, they want the study to be drawn on every single chart bar. In that case, that's going to be automatic looping because you want it to literally be drawn as far back as you can look, right? But you need to also understand that if you are loading a chart with many days of data loaded, and potentially a shorter term bar period, meaning there's going to be more bars on the chart relative to the days you loaded on the chart, it's going to take a longer time for that study to calculate. And this is the next thing, it's very important. Study calculations in sierrachart right now are still done on the primary thread of the software, meaning that if you have a lot of studies that are having high calculation times, it is going to, or it has the potential to slow down the user interface of the software. So this is why this is very important. If you're a general user of the software and you don't code custom studies, then you still need to be aware of this. If you do make custom studies, then I think this is important to learn about how to implement the manual looping. I'm going to show you an example of how to implement it and reasons as to why you would implement it or why not, okay? In this case, I'm going to press F5 to go into the chart settings. I'll go over to data limiting. In this case, on this chart, I've loaded 20 days of data. Now, I'm going to show you here. I'm going to close this. First of all, go into the studies menu and look at the calculation time for the moving average. It's 0 milliseconds, meaning that there is no calculation time. It's calculating immediately. It's very fast. If you look at moving average studies and exponential moving average studies, most of the time, they're not going to have a long calculation time, mainly because they're not very extremely complicated functions. Now, what you will notice here is that if I decrease the bar period of the chart, let's say I decrease it to 10 seconds. I'm typing 10S on my keyboard and then enter. Now let's let the chart load because it has to load 20 days of data. So we'll let that load. And now if I press F6 to go into my studies menu, look at the calculation time for the moving average, it's actually increased to 3 milliseconds. So really it hasn't increased a lot. Generally speaking, guys, the difference between manual looping and automatic looping on a moving average study most of the time is not going to be that apparent regarding the performance. Now, just to make this even more exaggerated, I'll drop it to 1 second and I'll let that load now and see what happens. So now I drop the bar period down to a 1 second bar period. And now you can see the moving average simple has a 14 millisecond calculation time. Okay, so we're still in our 1 second bar period chart here. And what I'm going to do is I'm going to add a version of the moving average simple study that has been modified to use manual looping. So I'm going to select Add Custom Study here. I'm going to find the study in my drop-down list of custom studies. It's called SMA Manual Looping. You won't find this in your Sierra chart because this is a custom study that I made. So I'll select Add. I'll add it in. Now, if we look at the calculation time, well, first of all, what we've noticed here is that I've added another study to the chart. The calculation time for the moving average simple actually increased itself slightly. That's something I noticed. Now, the second thing is if you look at the calculation time for the manual looping SMA, it's at 1 millisecond. So it's actually about 20 times more efficient than that one. And, just by generally looking at that, okay? Now, what you got to understand about the way this manual looping SMA is configured is that it's actually not set to iterate through every single bar on my chart that is loading 20 days of data. It's only iterating through 24 hours of data. That's the way I configured it. Okay, so with manual looping, you have to configure what is called the sc.UpdateStartIndex, and I'll show you how to do that next here, to basically be an array size of bars that is smaller than the amount of days that are being loaded on your chart entirely. So in this case, the length of our moving averages here are both set to, actually, this one is set to 20. If I increase the moving average simple, the one that uses auto looping, to 20, you will see the calculation time increase even more. Watch. Actually, it did nothing. It did the same. So we'll increase it to 100, and let's look at the difference now. So I'm increasing the length of the study. So there we go. Moving average simple is at 64. I'll increase the length of the manual looping study, and you can see that it barely increased it, just up to 4 milliseconds there. So there's a drastic difference between manual looping and automatic looping, especially if you're loading many days of data on the chart, using a short bar period, and you're using potentially long lengths for these studies, like a moving average that calculates 100 bars at a time. The higher you set the length, of course, the longer it will take the study to calculate. Okay, so now if we look at the chart, you can see that there's only one SMA value. It's this green line. And both SMAs are identical. That's why you're not seeing a difference, because they're on top of each other. They're on top of one another. Now, what I'll do just to show you guys the difference is I'll actually go ahead and put these both in chart region 2, just so you can see them both there and that they have the same exact values. So now both these moving averages are in chart region 2, and I'll actually go smaller so you can see that. There we go. So they have identical values right there, and that's why you can only see one line here. Now I'll switch the chart over to a 15-minute chart, let the chart load the data there, and I'm going to show you that the moving average that uses manual looping, it will stop. It will not be displaying data prior to 1 day ago. So let's just look. So currently right now, the time is around 2 p.m. Eastern time. If I go back the chart until 2 p.m. Eastern time the prior day, you'll see, well, now I'm pretty much there. Yeah, you can see here basically the SMA value for the manual looping study is at 0. Basically that it's not giving us data for that, that time, okay? So you'll see when it starts to come in is roughly around 2 p.m. And you'd have to kind of, there we go. So I can look right there. So you see it right around 2 p.m. it starts to populate with values. That is because I've specified the update start index for the amount of bars to iterate through to be 24 hours in the past. So I'm gonna go ahead and show you how I did that now. So I'll go ahead and go to my text editor. I'm gonna full screen this just so we can see what we're doing. And so as you can see here, on a basic moving average study, and now this applies to pretty much most of the studies that have these study functions, the built-in study functions in Sierra Chart. Sierra Chart's awesome because they actually created built-in functions that do pretty complicated math formulas like this one. sc.exponential moving average is a function that they created to calculate an exponential moving average. Now, the math behind an exponential moving average is actually quite complicated. It would actually take probably a decent amount of effort to code an exponential moving average, but SC is actually just put it into a function for us to use. So that's really awesome. So, okay, so now we'll go and find the SMA, which has been modified to do manual looping. So it's called SMA manual test or SMA manual looping. That's the name of the sc.graph name. Now, right here. So the first thing is that when you do manual looping, you need to specify a for loop before your initial study function. And the for loop, in this case, it creates a variable. In this case, it could be called whatever you want. It's called bar index in this case. And that variable is set to the sc.UpdateStartIndex. Just to keep this simple, this is basically set to, by default, it's set to 0, which is all the bars in the chart. So if you don't specify the sc.UpdateStartIndex, essentially your study is going to do the same exact thing as an auto looping study, and it's going to iterate through all the bars on the chart. But you don't want that. As a manual looping study, you want it to iterate through less bars. That's the whole point of creating a more efficient study function. There's a couple different ways you can do this. I'll show you the first method, which is actually quite easy. It's this one that is commented out right here, which is this line sets sc.UpdateStartIndex to be a set amount of bars on the chart. And that set amount of bars is set with an input. And in this case, I've specified it to be the same input that is responsible for setting the length of the moving average in this case. Now, what this is going to do is it's going to make your study very efficient because you're only going to be iterating through, for example, 20 bars because this input is set to a length of 20. Now, when you do this, what you're going to have on your chart is you're going to have a moving average that lasts from the current bar of the chart and it goes back 20 bars, and then it's going to show a value of 0 and it's going to be nothing. So if you use a moving average in the traditional way of using it, which is normally you want to display it across multiple bars or many bars, then that method's not going to be good for you. But if you use a moving average or a standard deviation or any one of these functions in a method that is unorthodox, potentially you just want to get a simple moving average or an exponential moving average of something else, and you don't care about seeing those past study values, then this code right here would be the actual most efficient, probably the most efficient way to do manual looping, because it's only going to be looping through 20 bars on the chart in this case. So what it's set to is sc.UpdateStartIndex is equal to sc.ArraySize minus the input. And what this will do is it basically sets the starting point for your study to be 20 bars in the past from the current time. That's what this line does right here. Now I'm going to show you the second method here, which is going to be slightly less efficient, but still a lot more efficient than automatic looping, which is to set the bar index, or the amount of bars to iterate through, to a specific time. In this case, what I've done is I've set the bar index to be a total of 24 hours. So it's going to iterate through 24 hours of bars on the chart, not more than that. These are the three lines that do that right there. So we have SCDateTime, it's called current time, that's the name of our object, is equal to this function, sc.currentSystemDateTime, and this is a function that SC created that gets the current system date time. Then we set a second variable, which is set by using the first variable and a built-in operator, again, that SC has created for us. So SCDateTime is called new time. What this line is doing is it is subtracting 24 hours from our first variable, and that is being now set into our second variable, which is called new time. And then what's done after that is this SCDateTime type is converted to an integer using this function, which gets the bar index. So what this will be getting for us is the bar that contains this time in it. And then what we do is we set sc.UpdateStartIndex to the bar index of that bar at that time that we got using these two functions, and that's going to allow us to have our study function only iterate through those bars. So the remaining code is as follows. The type integer here is called new time index is equal to this sc function, sc.getContainingIndex for SCDateTime. The first item here is the chart number, so you can actually set this to a different chart number. If you set it to sc.chartNumber, it's just going to work with the current chart, your current chart. And then the second item here is the SCDateTime object, in this case, new time. And that's all. So now we have this new integer that is set to this. And then we have this if statement, which basically just sets sc.UpdateStartIndex to be the new time index. When we specify sc.UpdateStartIndex here, it's automatically set to this right here. We have our for loop here, which basically allows us to iterate through a certain bar index before calling our study functions and setting the subgraphs with those study functions. Okay, that's all, guys. Hope this video helped you. Maybe it did, and I will see you guys in the next one. Take care.